I'm so excited to be here. It's been a dream to speak at DjangoCon since the day I started working with Django. First, I'd like to start by thanking everyone involved in making this conference happen, the complete DjangoCon organizing team, the volunteers team, and each one of you present here. You folks is the reason why we are having the virtual conference in the first place. Make no mistake, virus is still creating havoc out there, but as there is dialogue in Bollywood that the show must go on, and you folks are ensuring that show is going on, so kudos for that. Talking about myself, my name is Tarun. I work as an engineering manager at a startup named Stack. We are a startup based out of US and India, where our primary objective is to optimize big ticket B2C sales funnel by using a combination of data science and technology. Without further ado, let's get started with the talk. The title of my talk is Design Django Models Such That Your Future Self Will Thank You. I know that title might sound a little bit clickbaity, but I hope that the content that is coming your way will make it worthy. And if not, feel free to leave me a note on Twitter. My Twitter handle is in the bottom right, goes by Tarun_Garg 2. I'll take that as a positive feedback. And if you feel like that I made an impact on your learning positively, then also leave me a note on Twitter. That will just make my day. Moving forward, let's decompress what's coming up in this talk. First, we are going to be discussing what is this talk is about and why should you care. In this section, I'll try to explain what is the purpose of this talk, who is the intended audiences, etc, etc, and hopefully by the end of this section I'll be able to convince you to stick around for a little bit longer. Then we'll set up a premise. So how the rest of this talk will happen is that we'll set up a premise, and that premise will be building a product, and we'll go through the product development lifecycle of this app and see how at different points different learnings happen with respect to Django models. The idea again, the objective again would be to ensure that when you leave, you have a clear-cut idea as to when and how to implement those set themes. And all 5 themes that we are going to discussing about in this talk are auditing your models, timestamping your fields, soft deleting your entries, use of choices, and denormalization. Those are the top 5 key themes on which all of our learnings will be directed towards, and each one of them will be discussing when to use them and not to use them. In each one of them we'll discuss nitty-gritties of each of those key themes or areas, and then we'll end this talk with key takeaways and noting down the insights. First thing first, what is this talk is about? I've been working with Django since 2016, and in past 5 years I made a lot of mistakes with respect to Django and Django modeling. So this talk basically encompasses some of those learnings and mistakes I made in past 5 years. While I was building those asked product features, these were not so obvious mistakes, but it is in the hindsight only that those turned out to be mistakes. So my objective here will be to ensure that you don't make those mistakes again in your Django while you're designing your Django models, and you make new mistakes, and we all learn and grow as a community, and you design your Django models such that your future self will thank you for. These are essentially the things that I wish I knew I started. So I'm just telling you so that you know when you are starting. Although this talk is relevant for all programming levels, be it novice programmers, experienced or intermediate, everyone should enjoy this talk, and I hope you'll take out something good from it. So let's get started with setting up the premise of this talk. So for setting up the premise, I thought what would be the common ground that we all as an audience can relate to, and I thought let's build a messaging app. We all have used one messaging app or the other in our life till now, be it Slack, WhatsApp, or IRC, or Discord, or Microsoft Teams, or you name it. Every organization has a different form of IRC chat implemented. So I thought let's build in Yama. Let's call it Yama. Yama is yet another messaging application. Why Yama? Because why not? We have a lot of messaging app in our ecosystem, so we need to build a unified app that encompasses features of all of them, and that encompasses cons of each one of them individually. Obviously it's a joke, and the only reason why I choose Yama or building a messaging app is due to the fact that I thought we all can connect on that particular thesis, and all the incidents that I'll take you through in this talk are completely made up, and any resemblance with the real events is purely coincidental. It's better to clarify that. So far so good. We are going to be building Yama. So first let's look at what would be the high level database design of Yama. So in Yama, we would first have an organization, you can call it organization or customer or client or whatever you want to call it. Those are the basically buyers or of your product. So basically you would have an organization. Each organization would contain different channels in them, and each organization would have a set of users, and then users will post messages onto those channels, and users will also react to those messages. What do I mean by reacting is, users will post reactions like emoticons or reactions like thumbs up or thumbs down or spiral notepad or something like that. So this would be the high level database design of Yama would look like. I've also tried to depict what would many to many and one to one relationship would look like, although it might not be 100% accurate, but I hope it just gives you some idea. So moving forward, so we are building Yama. Let's get together to the adventures of Yama. Now suppose product team comes up and said that we need to add a support for adding a new user via user interface as well as CSV. CSV is comma separated values. A developer in me said, sure, we already have a user model for that. I'll just add the support for import soon. And what that user model used to look like back then was use classic Django stuff where user is inheriting from models.model, and user would have some fields like username, profile picture, and other user related fields. This would be the user model would look like. And I said, okay, I just add a support for imports on top of it and everything should be good. 3 hours later, product team comes up and said, hey, can you tell me why does this user exist in our system? A developer in me said, sure, allow me some time to debug. And exactly 10 or 11 minutes later, I realized that in order to debug why this particular user exists in our system, I need to know when this user was created. And I realized that I don't have that information in my schema because that was not the asked product feature. The product feature is supposed to just to implement the support for user. They did not ask that you might need when this particular user was created in the future, you might need when this particular user was updated in the future, etc. So that was my first learning was, and that's why the first theme that we are going to be discussing today, which is audit your models. So first let's discuss what is audit. And as with everything we do in programming as programmers, let's Google the definition. According to Google, an audit is an official examination of present state of something. Again repeating, an audit is an official examination of present state of something. You might think, how does this relate to Django or programming in general? So auditing your models means that have some metadata fields which will help you audit your models later. Speaking more practically, have some fields like created at or updated at in your model that will help you audit your model later, that when this particular model entry was created, when this particular model entry was updated. This is the most basic form of auditing that you might have in your Django model by having created at, where created at means when this particular model entry was created, updated at means when this particular model entry was updated. And I enabled both of them by using two Django constructs, which is auto now add and auto now. So this is the most basic form of auditing that you can have in your model. Then you can also have more advanced form of auditing by having things like updated by, who updated it, created by, who created it, deleted by, who deleted it, and raw JSON. Raw JSON can be thought of, suppose you are receiving a JSON from a third party and then you are transforming that JSON and then you are storing the transformed thing in your model, right, as separate values or properties, right? So in that case, if you will need to debug something in future that by this particular model entry looks like the way it looks like, you might need what was the raw JSON that was sent to me by this third party. In that case, in those cases, raw JSON might come handy to you. So this is the more advanced form of auditing that you can achieve by updated at, created by, deleted by, raw JSON, deleted at. And the most basic form can be achieved by created at and updated at. So this is auditing. But then there are some things that I learned from experience. First thing that I learned was what is the difference between auto now add is equals to true and default times dot now. I realized that auto now add is just a Django level construct, while default times dot now is a database level construct. What do I mean by that is, when you define an auto now add, so for the uninitiated, what is auto now add? So when you do auto now add on a model property in Django, what Django does is, when you are trying to create a new model entry, the fields with auto now add will get auto populated with the current timestamp. Okay. So, but this is, I realized later that this is strictly a Django level construct. It is not database level construct. What do I mean by that is Django sends the current timestamp value to the database does not generate it automatically. While having default times.now means that if you don't supply the value of this particular field, right, my default value is gonna be the current time. So default times.now is a database level construct, while auto now it is a Django level construct. And what difference it makes to our lives is, for example, you are trying to control your model, or suppose you are trying to insert in your model through a raw SQL, and that raw SQL is done by either some third party or some lambda code or some code in your application only. For some reason you cannot use Django objects.model.objects.create or model.save, and you are trying to insert by raw SQL by writing SQL statement, insert into, etc, etc. So in that case, the fields which have auto now add, you will have to manually supply the value, or the database will either throw an error or just stores the null value. While in the later case, if you have default times out on now for that field, the database will automatically take the value as current time. So this is one difference it makes. Another difference it makes is while testing. So in testing, if you're trying to create an instance of the past, right? For example, for some test, I want to create an instance which was 30 days earlier for some reason, right? Then it is that difficult to do with auto now add, but with default times out now it is pretty easy, because you can just supply the value and database will say, oh, you have supplied the value, I'll ignore the default and your value I'll consider it as truth value. But while in case of auto now add, Django will try to supply the value no matter if you have already supplied it or not. So this is some things that I learned, and I realized that default times out now might just be a better choice than auto now add for my use cases. Another thing that I learned from experience was the performance implications of having raw JSON in your model, and why those performance implications come about in the first place. First is due to the reason that Django defaults to fetching all the fields. What does that mean? That means that if you have 10 fields in your model and you say Django model.objects.filter, then all those 10 fields would be fetched for the selected rows, right? And think if you have a JSON field as one of the fields in your model, what that would do is, if a JSON has, for example, in size 2 KB or 5 KB or 1 MB for that matter, your database requirement will increase, your database memory requirement will increase, and your application memory requirement will also increase, because you are now also having that raw JSON in your memory, right? And it is not only the memory increase, due to that application performance or compute also takes a hit. The second reason of having performance implications while having raw JSON is due to the way Postgres handles oversized attributes. So Postgres has a concept called as toast, where every table you create in Postgres also creates a complementary toast table, where every oversized row, what is an oversized row? A row which is not fitting into the minimum size, maximum page size in Postgres, which is I think of 8 KB. Out of that, I think 2 or 4 KB is used for storing metadata around what is the next pointer, what is the previous pointer, header, checksum, etc, etc. And the rest of the 4 KB is the actual data. So any row which is exceeding that 4 KB, what Postgres will do is, first Postgres will try to fit in using compression or encoding or something of that sort. If it still does not fit, Postgres will break this data down and will also store that particular information that this row has been broken down into multiple pieces in your toast table. So whenever you are trying to fetch it, it will also go via toast table to fetch, to collate all those different, all the rows data that is contained in the different blocks in your disk, right? So these are the two reasons why having JSON in your model is considered to be a non-performant way. So what is the solution? I have already told you the problem. What is the solution? First solution, I realized that evaluate for a use case whether you really need raw JSON, right? Because after all, it is a good to have. It is a good to have in the sense that you might need to debug it later, right? So evaluate for a use case whether you really need, or maybe you can just go away with logging something in some other database or an ELK stack or something of that sort. That might also be solution. If you really need raw JSON, then consider having that JSON as a one-on-one field in some other model. So you can create another model which will just have that JSON field, and this model is related in as a one-to-one relationship with each row of this model, right? So what that would do is that this main model is same, does not have any JSON value, and if you need to know the JSON, you can anytime go to this particular related model and get the JSON, right? So that way, the first problem that we had, which was Django defaults to fetching all the fields, and due to which the performance implications came in, is also removed. Another way to remove that performance implication is maybe you can override the Django manager for that particular model, and you can override that manager to defer fetching the JSON, so that when you need JSON, only then you fetch it, you don't fetch it needlessly. Both are valid solutions. I have preferred in my experience to go with this because this looks like a clean way to go about this. So these are the things, some of the things that I learned from experience around auditing your models. So with all of those learnings, now we can alter our Yama user model with, we added, created at, updated at, and other auditing fields in our user model. You notice here that created has a default of timezone.now. I think timezone has a spelling mistake, apologies for that, but created has a default value of timezone.now, and updated at is being populated by autonow, sorry. So this is first learning that we had, which was around audit your models. While I close out this, I'll also leave you with something that you might have already heard of, something called as YAGNI. YAGNI is a software engineering principle, which is an acronym for you aren't gonna need it, but I'll just throw in a different term which will go about you will not regret it. So auditing is such a easy thing to do in Django or many modern programming language. Either they provide a native support, or there's some library or the other who is able to, who can enable you to do so. So it is very easy to do, but the benefits it has are tremendous. So you will not regret having auditing your models. If you can't do any fancy auditing, just do very simple thing, which is created at and updated at, and see basis your use case if you need more. So this was our first theme, which was audit your models. Again, let's go back to adventures of Yama. Now product team came up with the requirement that we need to add a support for bookmarking a message in a channel. What is a bookmarking? Bookmarking means pinning a message, if people familiar with Slack, or saving a message, or something like permanently pinning that message onto that channel. Bookmarking can be thought of something like that. So a developer in me said, sure, we can just add is bookmarked flag in the message, and whichever message has is bookmarked as true, that particular message is a bookmarked message, saved message, or a pinned message, and by default all of those messages will have this value as false. All good till now. 3 weeks later, this time nothing dramatic happens, thankfully, but I realized that boolean field can be swapped with something better here. What is that something better? Is basically what is our second theme is about, which is timestamp your fields. So first, let's figure out what is timestamp. As with everything else, let's Google the definition. A timestamp is a digital record of time of occurrence of a particular event. Again repeating, a timestamp is a digital record of time of occurrence of a particular event. But how does this relate to here? How does this relate to the incident that we talked about? So in the incident we talked about, we created an isBookmark field which has two values, true and false. If the value of that flag is true, that means the value of bookmark is true. If the value is false, it is false, right? What timestamp your field says that instead of having these boolean flags, what you can do is you can have these datetime fields instead, right? What that would do is, if bookmarked at has a datetime value, it means this particular message is bookmarked. That means it is a truth value. If bookmarked at field has a null value, that means this particular message is not bookmarked. That means it is a false value, right? As you can see here, all I wanted to know is whether the particular message is bookmarked or not, right? I am able to do so using both the solution, by having is bookmarked also, by having bookmarked at also, right? But the benefits that you have with bookmarked at is as that you get more data, more information about your data structure, about your underlying model, about your underlying data manipulation without any extra cost, right? So the essence almost remains the same, but having timestamp field just provides you more with more data. It's like free of cost more data, right? So this is basically what is meant by timestamping your fields, which means that instead of having Boolean fields, maybe you can swap them with datetime fields. The essence remains the same, but the benefits is usually much greater. There are things that I learned from experience. So when I first pitched this idea to my team came up with a, I would say, question or doubt that, it might very well be that storage cost will increase due to that. Sure, it might increase. I'm not sure how that particular database that we are using deals with Boolean fields and datetime fields. Definitely storage cost might increase, but my point here is the storage cost is almost negligible, especially when compared to today's world where storage is getting cheaper day by day. Storage is getting more and more commoditized, right? So storage is getting more cheaper day by day, and if there is a comparison between storage and the computation or developer experience, I'll always prioritize computation and developer experience because of the same reason that storage is getting cheaper day by day. So storage cost is almost negligible as compared to readability and other benefits it provides. Another realization that we had is that it is almost impossible to replicate it for null Boolean fields, because null Boolean fields has 3 states to maintain, and you cannot maintain 3 states by having just one variable. Boolean fields used to have just 2 states, which is true or false. You can maintain 2 states by just having one variable, but it is impossible to maintain 3 states by having one variable. You will again need to have more than one variable in order for this particular theme to work out. Another realization that we had is that it is not a divide between timestamp or Boolean field, right? Sometimes you got to have both of them also. One example that I can think of is, suppose you have a toggle which is constantly toggling between on value and off value. In that case, well, you can just have, when was this toggle turned on value, and whether if that value exists, that means the toggle is on. If that value does not exist, the toggle is off. But you might also want to know when the toggle was turned off, right? In that case, you will have another datetime field, right? So, and there are certain legit cases where, you got to have both of them also. So again, reiterating, it is not a debate between either this or this. Both can be complementary to each other also. So with these learnings, now we can change our message model schema with, again, having created and updated at all those auditing fields that we needed, and we can now have bookmarked at flag, which is a datetime field which null is with null is equals to true, where null value would mean that this particular message is not bookmarked. A datetime field there would mean this particular message is bookmarked. Again, throwing around what I said in theme 1, you will not regret it, right? Moving forward to the next Yama adventure, product team again came up and said, hey, now our app is getting traction. Now we need to add functionality for letting a user delete a message. A developer in me said, sure, that sounds pretty easy, right? We can just add deleted at in message, not is deleted, because we have already had those learnings in the past that you should not have is deleted. You should have deleted at to give you more visibility around things, right? So I said, sure, we can just add deleted at in the message. So I added a deleted at field in that message model. So in future, what happened was every query that involved message, we had to make sure that we incorporate deleted at is null condition in that particular query. And as the team grew, as the number of business analysts, as the number of data analysts, as the number of operation analysts grew, it became a pain to pass on that context every time, right? It became a common source of error, right? Sure, you can just add a view, Postgres view on top of it and say that, okay, just query this view, and what this view is doing, this view is just fetching all the rows with deleted at is null automatically. We can have that, but then this view just becomes another thing to maintain, right? Another thing to take care of. Another thing that we realized was that for an organization where deletion was a frequent operation, meaning that number of deleted rows is greater than 15% in number, then also it became a performance overhead to maintain. It was not performance issues, it became a performance overhead to maintain. Why? Because now your database contains many dead rows which nobody is using. They're just occupying space in your database, in the table space, right? So every time, first problem is already there, that every time you are creating any index or creating any query, you have to make sure to add deleted at is null is equals to flag, deleted at is null condition. The second is it just became a performance overhead to maintain. With all of this, we come to our next theme, which is soft delete or not. So what is soft delete? But this time we are not going to use Google, we are going to use DuckDuckGo. According to DuckDuckGo, soft delete in database lingo means that you set a flag on existing table which indicates that a record has been deleted instead of actually deleting that record. That's what we were doing in the past, right? We had a deleted at property in our message model that used to denote whether this record has been deleted or not instead of actually deleting that record. So basically we were doing soft delete. So a developer in me had this curiosity that why should I do soft delete, or should I just go ahead and do a hard delete and store the deleted data in some archived form? How should I make that decision, right? Is there a case where I should just go berserk and do hard delete and store deleted data in archived form? And with that curiosity, I reached out to my mentor, and as with any experienced programmer would say, they said it depends. It depends on what? That was my next question. So they said it depends on, will you need to reference that data? That data means the deleted data for frequent use cases. The main point here is that will you need to? You might want to, but will you need to reference that for frequent use cases? If you don't need to reference that data for frequent use cases, it might be very well that you can just hard delete it from the main table and store it in some archive table, so that if you need in future for any infrequent use cases, you can just take from that archive table. That was the first case that they said, first condition that it depends on. The second thing she said depends on was what will be the ratio of deleted entries and live entries. If you think that deleted entries will go above 10% or 20% of the live entries, then it might make sense to have that deleted data in an archive table instead of having it on main table, because having it in main table will just make your performance worse and worse, and it will be just another performance overhead to maintain. Another thing that she said was, what will be your query pattern look like? Identify what would be that query pattern would look like. If your query pattern would always be that I'm always gonna be fetching live entries, then probably it indicates already that you should be better off with having a hard delete and storing it in some archived form. And if you think that your query pattern might increase often, referencing that deleted data, then you might have to think about it whether you should do soft delete or not. So with that, she finally concluded that it depends on these three factors, and on the basis of these three factors, I came to a conclusion that in our case of Yama, we rarely need to fetch the deleted messages except for compliance audit or something of that sort, which is a once in a lifetime operation or once in a year operation or something of that sort. So with that particular information, I created a deleted message model which had exactly the same properties and attributes as the original message. Again, you need to evaluate for your use case whether you should do soft delete or not. Don't go by blindly that you should always do soft delete or you should always do hard delete. Remember that there are both these options available, and evaluate basis your use case. Coming back to adventures of Yama again, now product team came up with another product requirement which goes by that we need to define roles for user, and those roles can be admin and normal user. Now at this point I had around 2 years of Django experience, so I knew there exists something like choices in Django. So I said sure, we can just add role field with choices in user model, and with that I implemented that, and this is what the implementation looked like, where I would have choices, and choices are usually list of tuples, where the first value of the tuple is what actually gets stored in the database, and second value is what is shown on the model form level. And I defined a positive integer field with choices as these user role choices. And what it used to store in database is that here you see a user with test for username gets stored with the role 0. 0 refers to normal. Test5 username gets stored with role 2, which refers to archived. And anytime somebody wants to know who all are the admin users in my system, they would just go and query select star from user where role is equals to 1. So I implemented this choices thing. Things were good until it wasn't. Again, it became a context problem to remember all the numerical mapping for roles. Consider you have only 3 mappings as of now: admin, normal and archived. And in future, suppose that 3 increases to 10. Now as a developer analyst or data analyst or business analyst or operation analyst, you will have to remember all that numerical mapping in order to make sense of the data that you receive from your database, right? So remembering all that numerical became pain, and as the number of fields with choices increased, it all became more and more painful. Another thing that we realized was that Django choices are just a model form level constraint check. That is, it does not ensure constraint and quality check at the lowest level, which is the database. What that means is that if a developer comes in and says that okay, user.role is equals to xyz, and that xyz role does not exist, and say user.save, that will work. Why? Because you're not interacting with the model form anywhere. Django choices are just model form level constraint check. It is not a constraint check on the database level. So if anyone tries to directly manipulate the database state, he or she will be able to do so. So it was another learning. So with that, we jump to theme 4, which is use of choices. So things I learned from experience in use of choices are, first problem that we had, if you remember, was that remembering all that numerical mapping was becoming a pain. So this was the first learning that we had, which is basically keep strings instead of numbers for values. The benefit outweighs the disadvantages. The only disadvantage I can think of this approach is storage. The storage might increase, but keeping string instead of number also reduces the contextual overhead for data analyst, business analyst, operation analyst and developers also. Now if they need to know what all the normal users in the system are, they can just go select star from user where role is equals to normal, right? They don't need to go and check what is the numerical mapping looks like and then do all of that fancy stuff. They can just search by a role is equals to normal. So it reduces that overhead, and again the benefit outweighs the disadvantages that you might have. Another problem that we had or started having was, as the project grew, right, the number of fields with choices increased a lot, and as the number of fields increased, it became harder and harder to maintain those choices in the code, right, because those choices need to exist in the code also somewhere, right? So this is the another thing that I learned from experiences: keep choices as constant variables and as namespace as possible, right? So consider here in this example, I've created a user role class which is inheriting from models.textChoices. Models.textChoices is the recent feature released by Django, which helps you namespace your choices. So I have namespaced all my choices under a class name user role, right? So anytime I will need to reference normal user role, I can just reference it by user role.normal, right? If anytime I need to reference all the choices, I can always reference it by user role.choices. So this is the benefit it provides. As your project grows, as the number of developers you add in your team keeps continuously increasing, having these choices as namespace as possible provides many advantages. Another problem that if you remember, we had was Django was not enforcing those constraints at the lowest level, which was the database. So we realized that okay, we can have those check constraint on database level by having something like this, which says that okay, before inserting into database, check if the value lies in between these values, and if it lies, only then let it insert. If not, throw an integrity error. So basically this is a constraint that you can create on database level. With that, we can move to our next adventure of Yama. So till now we have covered auditing, we have covered soft delete, we have covered timestamping fields, we have covered use of choices. So next adventure of Yama, again product team came up with a requirement that we need an hourly report to get the number of messages sent in each organization. A developer in me said, sure, that looks like an easy requirement to implement, consider it done. And I created a cron job or a scheduled job that used to run the following SQL query every hour, where the SQL query used to work like that. It used to fetch the messages from the message table, used to join on user, then used to join on organization to reach an organization, because message is related to a user and the user is related to organization. So to reach organization, we have to have a join. And then I used to group by one means org.name. right? So this was a SQL query that I used to run every hour to get a report of number of messages sent in each organization. Things were good in Citadel until one Friday our database server crashed due to this query, and on debugging we figured out what was the reason for crashing of database server. It was the expensive join cost between user and message for some of the organizations. So that led to our last and final theme for this talk, which is denormalization. So when talking about denormalization, let's first discuss what is denormalization. And this time, let's use Bing as a search engine. So according to Bing, denormalization is the process of adding pre-computed redundant data to an otherwise normalized relational table to improve the read performance of the database. This part is important. The process of adding pre-computed redundant data to an otherwise normalized relational database to improve the read performance of the database. So this is denormalization, and we thought maybe denormalization could help us here, but we were always taught in academics that denormalization is bad. Normalization is the holy grail solution of everything in database. If you do denormalization, you will have problems like update anomalies, insertion anomalies, selection anomalies. Make no mistakes, those principles also are true, but it is okay to denormalize. In fact, denormalization is one of the top reasons why new age databases are able to scale up. This is the first acceptance that we needed to have as an engineering organization, that it is okay to denormalization. It is okay to do denormalization. So with that realization, let's discuss what does the before and after scenario look like. So before denormalization, what our Yama database model used to be look like is an organization is related to a user and a user is related to a message. After that realization of denormalization, we thought, hey, maybe one option that we could have is directly relate a message to organization, so that the join between that user and message, which was causing that problem, does not happen at all. We remove that completely out of that equation. That was the first option that we considered. And if you think about it, that also makes sense, right? You will rarely find a case where you will need to change an organization altogether for a message. And if there would be some cases, it would be pretty rare. Another option that we thought of was, if we are going to have denormalization, why not just store messages count along with organization? So anytime a message gets inserted into the message table, I also increase the message count in the organization, right? It has some implications on write performance that we are going to be discussing about that in the next few slides. But we thought, oh, maybe that could also be one of the solutions, and that is a solution that we went ahead later on, that storing messages count along with the organization. So this is how denormalization helped us solve that problem. But as with everything else, there are some things that I learned here also from experience. First thing I learned was everything done in excess is bad, and the same is true for both normalization as well as denormalization. Again repeating, everything done in excess is bad. The same is true for both normalization and denormalization. Normalization, if done in excess, affects your read query performance, because then you will have to have complex joins, complicated joins, etc. But denormalization, if done in excess, will affect your database integrity if not done well, will affect your database constraint if not done well, because now you need to maintain that integrity by updating at two places. What is being told to us in academics, right? That is what update anomaly is about, that if you update one thing, you will need to remember to update another thing. That is the same problem with denormalization happens, right? But if done in excess is when it is bad. If done in moderate amount, it is okay to denormalize. Another thing that I realized was everything done in software optimization is a trade-off, and here the trade-off is between faster reads and slower writes, which is the case of denormalization, versus faster writes and slower reads, which is the case of normalization, right? In normalization, you have faster writes because you are doing atomic writes, but reads are slower because of joins. In denormalization, reads are faster because you have removed joins, but writes are slower because now you need to maintain constraints, integrity, etc., manually while writing to your denormalized tables. So it is also a trade-off. So it is important to realize that denormalization is okay, but done in excess is bad, and it is a trade-off between faster reads and slower writes versus faster writes and slower reads. With that, we are good to close our talk. and it is time to bring down the curtains. Before I, tell you about key takeaways from this talk, I just wanted to explicitly state it out that don't follow any advice blindly from me or anyone without evaluating for you your use case. I have made these mistakes multiple times in my career where I said, oh, X person is saying that we should do this, let's do that. Then for my use case, I realized, oh, this particular thing was bad for my use case due to XYZ reasons, right? So evaluate for your use case, see if it really makes sense, see if you see any disadvantages, see if you delve deep into each of these concepts after going home and see if some of those make sense for you or not, and then only try to implement it. Don't follow anyone blindly, for that matter, me also. So with that, let's note down key takeaways from this session. First was auditing your models can go a long way in making debuggability easy. And most simple form of or simplest form of auditing can be achieved by adding created data and updated data in your models. Another learning that we had was when tempted to use Boolean fields for something, evaluate whether you can use timestamp fields instead. It helps you kill two birds with one stone. I do not recommend killing birds, but it's just an idiom. Another learning that we had was soft delete is good, but it can be root of problems also, so evaluate. I, at this point in my career, of a believer that we should do seriously think about hard deleting, and if there is no strong reason for soft delete, then don't do soft delete, because soft delete can be root of your performance problems. Use Django choices wisely and maintain consistency using check constraint or something of that sort. And the last, denormalization is okay and is a trade-off. So with that, I am good to close this talk, and I'm open to any feedback or questions that you might have. My Twitter handle is Tarun_Garg2. If you have any positive or negative feedback, feel free to leave me a note on Twitter. I'd like to hear from you. And if you are more active on LinkedIn, below is my LinkedIn handle, Tarun Garg546. Feel free to reach me out there also. With that, it's time to say goodbye. Goodbye, take care, stay safe, get vaccinated, and I hope we'll be able to see each other in person next year around. Take care, bye bye.